right, so hello everyone and welcome again. Apologies for getting started a bit late. This is the UCR Library Workshop, Introduction to Text Mining and Analysis. My name is Rachel Starry. I'm the Digital Scholarship Librarian here at UCR Library, and we're going to go ahead and get started. So before we dive in, I do want to just take a moment to acknowledge that we're all living in really challenging times right now. So I want to acknowledge that the pandemic and other structural inequalities have disproportionately affected people of color, particularly Black and Indigenous peoples. So as a member of the UCR community, I stand with Black Lives Matter against racial injustice, police brutality, and other human rights violations. I also want to take this time to recognize our responsibility to the original and current caretakers of this land, water, and air, the Kuya, Tongva, Luiseño, and Serrano peoples, as well as their ancestors and descendants, past, present, and future. And while we're currently meeting in a virtual space, not on Riverside's campus, I do invite you to learn whose ancestral lands you're physically located on, wherever you are calling in from. And a great resource for that is on the screen here. It's native-land.ca. So essentially, I recognize we're all in different kind of physical spaces right now and all of that. So feel free to engage however you're comfortable today. You can always follow up with me by email, or I have a link at the end of the slide deck to, ask a librarian. So do feel free to ask questions throughout. I'll monitor chat, but hopefully the information that we go over today will be helpful to you all. So the goals for today are kind of twofold. So again, in the remote setting, it's a little bit challenging to do a lot of hands-on sort of exploration together. If you do have a second screen, you might be able to have the slides or my screen share up, and then also be exploring Voyant tools at the same time if you want to kind of follow along. But also feel free to just kind of take this as a demo and see the possibilities. So the goal is kind of first to just kind of cover and demystify some of the terminology and go over some of the significant methods and techniques that are used in computational text analysis, particularly in the realm of digital humanities. So a lot of what we'll talk about is, and I know we have some linguistics and English folks in the room, so some of you may also be expert in this in your own right, or use different terminology in your disciplines. So just kind of want to cover those bases. And then we'll take some time to do a demo and look at one particular online tool for exploring patterns in text, and share some resources again in the slides for you to kind of be equipped to go out and learn more on your own. So to start off, what is text mining? And I'm using these two different phrases, text mining and text analysis. So to start with the first, there's a kind of basic agreed upon definition that is deriving high quality structured data from texts. So I want to interrogate those three different parts of this. So high quality, right? This means that the data that we're extracting from text is interesting in some way, that it is, the computer's not just detecting noise, but when we process and analyze text into structured data, that we pay attention to patterns that are in some way new or relevant to our research questions and hypotheses. Structured, that piece, right? So plain text, just a text document, is unorganized. They're just strings of letters and numbers. So text mining techniques let us detect patterns and organize those characters, words, or even sentences into an organized data model that can help us and the computer recognize relationships between those characters, words, sentences, even whole documents. And we'll talk about some of the terminology. We get into documents and bodies of text, collections of text. So I'll define those words as I start to use them. And then the data piece of this, right? Data is information, but it's more than that. It's useful information that can be analyzed to help us better understand something, right? So text can be treated as data, particularly now with these massive amounts of information that are being produced and collected by websites and companies like Twitter, Facebook, Google, even Wikipedia. Text has entered the world of big data. So the data mining of text has become increasingly important to researchers in academia and various disciplines and across different industries, right? So what does text mining actually look like? So at its most basic level, text mining involves a lot of different kind of common text processing tasks, such as tokenization. That's just splitting documents into individual words or tokens. N-grams are, essentially phrases. They're contiguous chains of n number of tokens, words. Unigrams, you'll see different, unigrams refers to one word phrases, so just a token. Bigrams are two word phrases or two chains. And so most of the time we'll want to count or analyze individual words. But sometimes we care about things like proper names or phrases or, multiple words chained together, and n-grams are a way to describe that. We generally care more about, words that are interesting or unique to a document or corpus. A corpus, again, being a collection of text, a body of text is just a Latin word for body. So, text processing and analysis typically removes what are called stop words, lists of words that are very frequently used, conjunctions, prepositions, articles, a and the, and but, all of those kinds of words. We care less about the frequency of those words. In most cases, there is an example we'll look at later where that's not really the case. So sometimes we'll want to strip out things like punctuation, like special characters, all of that. So that's a common task. Another thing you'll commonly see kind of in this realm of kind of text processing, text mining, is something that's called computing term and document frequencies, which is abbreviated TF-IDF. So this sounds really fancy, but it's actually a pretty straightforward calculation or calculations. So term frequency is just how frequently a word occurs within one document, right? It's generally expressed as a fraction, as a decimal number, representing, the fraction of that one word, the raw frequency of that word, out of the entire, total word count of the document. Inverse document frequency identifies how common a term is within a whole collection. So term frequency is just for document. Then inverse document frequency is for the entire collection of documents, the corpus. It's a great question, Kurt. So this statistic helps us decrease the weight for commonly used words, in the English language, for example, or any language you're analyzing, and increases the weight for words that are not used very much, that might be interesting for us to kind of dive deeper into. So common terms that occur in pretty much every document will have an IDF of 0, really common verbs, things like that. But very unique words for the corpus, for the collection of documents, will have a higher value. So all of those common techniques that I just mentioned kind of fall under this umbrella of an approach to text mining called the bag of words. So this description kind of illustrates how researchers often ask computers to read documents as just a collection of words separated by spaces without any, logical order or meaning. So with this approach, we're not asking the computer to look for meaning, but rather to look at patterns at a scale that it would be impossible for humans to do manually, right? When we're talking about, seeing how frequently a word is used over a corpus of 1 million documents that span centuries in a collection like the HathiTrust Digital Library or Google Books, and we'll actually just look at HathiTrust really quickly in a minute. You have to use a computer to parse out individual words and do all of that counting and frequency calculations for you. There's just no other way to do it. And we can derive a lot of meaning from the kind of quantitative, descriptions of documents from these really simple bag of words approaches. Like the most frequently used words in a political speech, for example, can tell you pretty accurately, what the speech was about, what ideas the speaker was emphasizing. We could question things like the vocabulary density of Shakespeare or different politicians or whoever. We can investigate the co-occurrence of words, where words occur next to each other and in phrases. So we could ask questions like, do female characters in science fiction novels use more action verbs than male characters or fewer action verbs, or compared to, words used by different characters in, other genres, historical romances or whatever. So there's a lot of really interesting things that we can do with just these kind of simple text mining approaches. So what then is the difference between text mining and text analysis? If order isn't accounted for, how does one get co-occurrence? Also a good question, Kurt. So in that sense, there is some calculation of distance between the words. So it's not entirely a bag of words approach, collocation. That one is a little bit more sophisticated. But that's where we kind of come down to, why I'm using this distinction between text mining and text analysis. Because all these different words are kind of used interchangeably and, by different folks in different contexts. So there are these approaches of analyzing text that go beyond the bag of words approach and the simple text mining techniques that I just mentioned, right? So, a lot of these fall under the heading of natural language processing. So we'll look at those in a minute. But essentially, if text mining, and this is what I have on the screen here, if the goal of those processes and activities is to just get the high quality structured data, a lot of that quantitative just counting and frequency analysis, then text analysis, natural language processing approaches are the study of that high quality structured data. So a couple of the different natural language processing approaches that do go beyond the bag of words and examine the semantic patterns in text. So, here we care about things like the order that the words are used in, how far they are, like the question that was just asked in chat, they are away from each other, what parts of speech they represent, and the meaning of words in context. So one really common NLP technique is called named entity recognition. So this is the classification of words and phrases into predefined categories, everything from people, places, dates, organizations, numbers, quantities, percentages, dollar amounts, things like that. So all of these, and this approach and others that we're going to be talking about are pretty much, they're based on machine learning. So a lot of times the training data that was used to create this particular a particular named entity recognition algorithm will determine how effective that algorithm is when applied to your particular collection of documents. So that's something to keep in mind, and we'll kind of talk about at the end of today some of the different tools that are out there for different languages and all of that. So in addition to named entity recognition, another really common natural language processing technique is part of speech tagging. So words obviously can act many different ways in a sentence, and that can change their meaning and can change how we interpret them and understand them. So the word book obviously can be a noun. It can be the subject of a sentence, like the book is on the table, or it can act as a verb, right? It can be a totally different word. I need to book a flight. If you're analyzing a cookbook, for example, you might want to know when the word pound means a weight of an ingredient versus an action that you do to break an ingredient down into smaller or flatter pieces. So this is related. So a lot of these you'll probably be kind of doing at the same time or in parallel and taking that information together. So part of speech tagging is related to word sense disambiguation, which is of course homonyms, words that are spelled the same or sound the same, are fairly common in English, of course many other languages, especially those that are inflected or rely on tone to convey meaning. So word sense disambiguation is related to part of speech tagging, but goes further, right? So when a noun like BASS, bass or base, it might mean multiple different things, even if it's serving as the subject of a sentence. So this word could be a type of fish, tones of low frequency, or a type of musical instrument. Also related to this is a kind of pair of processes called stemming and lemmatization. So stemming is essentially stripping the inflected endings off of a word so you can group, all occurrences. So when you're looking at your document, you probably want to know, how many times was the verb argue mentioned. But to do that, argue appears in multiple different forms, different tenses, different persons, all of that. So you'd want to be able to group all of those different uses together into just one one word or one token. And so you can do this a couple of different ways. You can do it through stemming, just chopping off the end of these words. So a stemming algorithm might reduce all instances of argue to just the stem, just the core part of the word with the inflected ending chopped off. You're going to lose something here, though. So you'll end up with something like ARGU, for ponying up, ponies, pony. You're only just going to get pone. That's the stem. So it's kind of a less nuanced way. It's just chopping off the end of words. So that's different from lemmatization, which is also the process of grouping together different inflected forms of words, so they can be analyzed as a single item. How many times is the helping verb to be, or state of being verb, or whatever it's called, used in this document? But to do that, you need to know, or the computer needs to recognize that the words am, is, are, all need to be combined into that form be. So this involves, of course, like dictionary lookup. So the goal here is, rather than just chopping off the end of the word, to actually return the root of the word, or lemma. So it's a little trickier to identify because that depends on correctly identifying the part of speech, right? As well as the kind of larger context and meaning of that word within the sentence. So here the goal would be not to return the kind of arbitrary PON root of ponies, but to recognize, okay, ponies is the plural of ponies. I'm going to return that and group all those words under this lemma. Any questions so far? Definitely feel free to throw questions in the chat. I know I'm moving kind of quickly too through these. So what are some of the kinds of research questions that folks in different disciplines are asking using these sorts of text mining and analysis approaches? So a lot of the kinds of questions that we can ask are, bigger picture, kind of higher level questions about documents. Obviously, things that we wouldn't be able to ask if we were just, or that would take us a long time if we were manually kind of reading through all these documents as humans, right? So we can ask bigger questions when we're computationally analyzing bodies of text, right? So we can study things like how an author's style changes over time, or even how genres develop, and even how genres are defined. Of course, that conversation's been happening for decades in the kind of literary analysis sphere. So was Shakespeare's vocabulary really unusually large compared to his contemporary writers? Do authors' styles change when they dictate versus write their texts by hand? Things like that. We can also test hypotheses about texts or passages and quantitatively kind of describe and compare the similarities and differences at a higher level, right? So a lot of times text analysis is called distant reading compared to, in different literary fields, close reading, where you're investigating text really, up close and like digging into small level relationships between different words and phrases. So a lot of the kind of computational methods that we're talking about today are kind of best when they're combined with the more traditional methods of studying all of these things, right? A lot of what we're talking about today is less a way of answering questions and more generating questions and places where you might want to look more closely or more deeply at your different documents or corpus. So we can also investigate the history of a significant word or concept over time, or even a group of words or concepts, right? So when was a word first used? Or when did a phrase become common in a particular language? So if you all are not familiar with Google Ngram Viewer, this is a fantastic tool that uses the Google Books corpus. I believe it's something like 5 million books up to 2008. And you can search for not just words, individual words, but also phrases and n-grams, right? So we've got a couple bigrams here with 2 words, and then Frankenstein's just one word, a unigram. So you can set all these different parameters. You can choose which corpus you're using, and you can read a bit more about the different corpora that Google is providing here. So you can kind of compare across different language corpora, different time periods, different time scales, the frequency of words relative to how they're used in all of the books in the corpus. So this is a really interesting tool. Another one, if you're not, you haven't heard of it, is Google Trends. So Google Trends is it's less about the historical context over time, and although a little bit, and more about what people are searching for in different parts of the world. So this is a nice thing to know about as well. So it's searching Google searches versus, the books that Google digitized. So you can, of course, look for different terms and where they're occurring over different time spans. So recently, and they go all the way back to 2004. So I believe that's when the data starts. So you can kind of view interest over time and in different places for different topics. So related, but, a little bit different. We can also investigate questions using these different text analysis tools and methods of authorship attribution, right? So who might have been the author writing under a particular pseudonym, or which songwriter actually wrote the lyrics to a song that was published anonymously or that's disputed, right? Which Beatle actually wrote the lyrics to that song? Was it John or Paul? Things like that. Researchers are using these methods to ask those kinds of questions. And we can explore thematic language in texts. Are there particular words or phrases that characterize the speeches of Dr. Martin Luther King Jr. in different years? Or quantitatively, are there different themes detectable across different Jane Austen novels? Obviously, these are also questions folks have been asking for a very long time without the assistance of computers. But again, a lot of these methods kind of help you move back and forth between a kind of higher level quantitative distant reading, and then those point to different interesting places you might want to investigate a bit further. So I thought it would be helpful to kind of make some of this a little more concrete, to actually look at a couple of different examples and talk through how different projects have actually used, how researchers have actually used these different algorithms and tools to ask and answer different kinds of questions. So these are just the links here, but I'll go ahead and click over here. So in this project, we're going to look at how they're using sentiment analysis. So this is a machine learning algorithm, or a variety of algorithms applied in different ways or implemented in different ways. But essentially sentiment analysis is the classification of words, phrases, and even times, entire documents, books, collections of books, according to the emotion, or sometimes called polarity, that they express. So words are assigned a positive or negative or neutral meaning, and sometimes that's split out into different degrees. And that can be interesting and kind of looking at, across a book, across a different, across even, one chapter of a book. Are there different, how does the kind of trend of, sentiment change throughout the document? So again, this is implemented in different ways. So the Lord of the Rings project is part of a larger project to analyze Tolkien's works. So Emilio Hansen, someone from Sweden, has analyzed the text in The Hobbit, The Lord of the Rings, and The Silmarillion using a bunch of different methods, including sentiment analysis. So in this example, they're summarizing the feeling, the sentiment, by each page. So they've, looked at each word, run the sentiment analysis, and, discovered what the general degree of sentiment was, positive, negative, or neutral, for each word, and then kind of summed that up by page. So there's different ways you can do this. But essentially this, kind of gives you a metric to compare across different documents. So you could ask questions like, so for example, I would have probably naturally assumed that The Hobbit was a more positive book. It's a children's book compared to something like, the hefty Fellowship of the Ring or the Silmarillion, things like that were intended for adult audiences. But in fact, there's a lot of kind of negative language, if not, negative themes or something more abstract in The Hobbit. So that's an interesting, kind of gives you a place to kind of poke around and look and see like, well, what are the words that are, being called out? Like, well, what is this telling us about these different novels, and allowing us to kind of compare? Like The Two Towers is like overwhelmingly positive. It's interesting. So this project has a bunch of other kinds of statistics. So Emil goes through and looks at, word frequency, unique words, all different kinds of things that you can explore through a project like this to see, where different words occur, how common they are across the corpus, etc. So kind of cool project. So another really commonly used algorithm, again, set of algorithms applied and implemented in different ways, is called topic modeling. So topic models are a way of statistically modeling the major themes and this is typically applied to really large collections of text. If you apply an algorithm or algorithms like this to a really small collection of texts, you're obviously giving the computer a lot less information to work with. So a lot of times these algorithms get better when they have more training data. And of course, if they're trained on different kinds of data. It's really important to kind of take a look at, for whatever tool you're using, what is the actual topic model algorithm that they're applying? How is it trained, all of that. This is an interesting project. Joya Stevens, who is the Special Collections Cataloger at New York University Libraries, or was in the past, I'm not sure exactly where they are now, assembled a collection of 1,450 cookbooks and government publications like cooking manuals, published for the Army, things like that, published in the US between 1800 and 1920. So they created this collection of cookbooks in the HathiTrust digital library. And if you're not familiar with HathiTrust, this is a really fantastic source. They actually have, I believe, easily 3 times as many. I forget the exact number of millions, since it's always changing every year as different institutions are adding to HathiTrust. But they have a huge range of different kinds of documents, full text documents, some of which you can view in full text, some of which you can kind of just search the full text but can't access the full text. So it's something called non-consumptive research. Not directly relevant here, but feel free to ask questions if you're curious about that. So this is a resource that is available to everyone here at UCR. So you can log in using your NetID or UCR ID credentials, and you can actually access information. So there's a really fantastic emergency system set up right now during the pandemic, so that you can access. We're not doing physical ILL right now. You can access HathiTrust volumes that are held by, for example, other UC libraries. So you can access sometimes the digital version, digitized version of different books if they're physically held in our sister schools libraries. So again, you can always go on the UCR library catalog and look for the HathiTrust digital library link. But again, this is a really fantastic collection of documents. Many millions of documents, many more than Google. The Google Books project has actually. So this is a place you can actually create collections of documents and then use them for text analysis. So I've done workshops in the past that work specifically on HathiTrust Digital Library and something called the HathiTrust Research Center, which has its own algorithms for implementing things like topic modeling and other algorithms. So that's something, if folks are interested in, we could do a workshop on that topic in particular, but we're gonna look at a different tool today. But just so you all are aware, HathiTrust is really fantastic. Back to the early American cookbooks project. So Joya went through and you ran a particular kind of topic model, which is called latent Dirichlet allocation. Not important in this context right now how that works, but essentially, I can actually go back here and we can talk about what topic models are. So what even is this when I say topic modeling? So the idea here is that this is a tool that lets you discover the abstract topics or themes that occur within a huge collection of documents that, again, a human could never sit through and kind of read. The idea here is you're taking, imagine you're sitting and reading an article with a bunch of different colored highlighters. And your plan is to, when you find a word that's related to, finances, you're going to highlight it in blue. And when you come up with a word that's, related to restaurants, you're going to highlight that in green. And at the end, you can kind of group those all together into different themes. So that's doable for the level of a couple of articles, not doable at the level of millions, thousands or hundreds of thousands or millions of documents. So that's where this kind of algorithm comes in handy. So, intuitively, I think we understand that, if a book is about dogs, there's going to be a lot of dog words in that book. There'll also be words like the, is, and, common words. In a book about cats, same thing, cat words, along with common words, right? So the goal with this is, because of course, what you have on the right-hand side is a lot more common. We don't just ever have, one topic in a given document or book, right? A document typically concerns multiple topics in different proportions. So, in a document that's 10% about cats and 90% about dogs, they're probably going to be about 9 times more dog words than cat words, right? So that's the idea here. The topics produced by these techniques are clusters of related words. So here's another example from that examined or processed 1.8 million articles from the New York Times. So another thing to kind of note with this is there's a lot of settings and parameters for any of these algorithms. So with this particular example, and I have a source citation on the next slide, or a following slide, how you run this algorithm and how it's trained and all of that matters. So for example, I imagine that when this, to generate these list of topics, the computer probably returned a lot more topics. Some of them are probably nonsensical, just because the computer thought that those words, worked together and made a topic. Doesn't necessarily, there's still an interpretive layer, right, that has to go on top of this. So I'm imagining that these 10 topics that they pulled out are the most coherent ones, right? They're really clearly like one of them's about music, one of them's about, books, one's about art, TV, politics, the economy, things like that. Again, topic modeling and a lot of these different tools that we're talking about, or methods, aren't always themselves the endpoint, right? The evidence, but they make a really great starting point, tool for discovery. So it's, of course, it's not the job of the computer to really, make sense of this. It's still, researchers' job to do the actual interpreting and understanding, but these are really great tools for doing that. So the topic models found in the early American cookbooks are interesting. And so, of course, Joya had to do analysis on top of this. So the topic models, I think, returned, something like 10 topics. Some of them were really coherent. So topic 1 was about seasoning. Topic 3 was about meats and sauces. And then some of them, there were just question marks about. They didn't have maybe as coherent, or maybe they require more investigation. Like, what is it that these words have in common? Like, why would the computer detect these? Is this about pickling? And then then you can dive deeper into your documents. She found some that were very clearly about specific kinds of recipes, so like bread. I believe there's one that's for cake, things like that. Even more historically specific things like jellies and lemonades, things like that. Do you provide the topics? You tell the computer how many topics to look for and how many times it should iterate, and depending on the training data that the particular machine learning model was created using, you can get different kinds of topics, but you are not the one providing the topics. The computer, you will say, I want you to find topics that are between 10 and 20 terms, words or phrases, and I want you to return 20 topics, a maximum of 20 topics. The computer will go and run and try and look at all those things, and then it will just return these chunks of these, buckets of words to you, and it will say, hey, did any of these make sense? And then just, it's kind of our job to go through and say, oh yeah, that one is like probably collecting all the kind of different commonly used words in recipes for cake. Or in the New York Times, obviously a topic that's about, the finances or the economy is really clearly separated in the language used than from like politics or restaurant evaluations, things like that. So here's some great, if you want to read more about topic modeling, these are some great resources. Ways to analyze documents. Would you also use some of these for open-ended survey questions? Absolutely. So I'm using the word documents and all the literature on this. So document, think of document as a very agnostic sort of word. A document could be a poem. It could be a novel. It could be the responses to an open-ended, like a qualitative survey. It can literally be anything, political speech. It could be, I'm trying to think of different things, a song. Really like these approaches are applied to a super wide variety of different kinds of texts. I mean, you could run this on, journal articles. People have done a lot of analyses of, the kinds of articles published in different journals or by different publishers, things like that. It's super widely applicable. That said, different text analysis approaches are going to be more applicable or less applicable to particular kinds of documents and corpora. So topic models, maybe that's less useful. And again, it is less useful for really small collections of documents. If you only have 20 documents, you can run topic modeling on those 20 documents, especially if those are really long documents, right? I'm not even talking about the size of a document. A document could be 1,000 pages, or it could be 10 words. But you're gonna get less, meaningful topics when run on a very small corpus versus 1.8 million New York Times articles. That's a really useful corpus to run topic modeling on. Great questions, keep asking them. So another example project I wanted to kind of talk about, we're not gonna look at this project, it's more of a historical story. So let me tell you a story about the kind of, one of the most classic examples of using stylometry to identify the author of disputed documents. So the Federalist Papers, and if you want to read more, I have a link here to, I believe it's a tutorial actually, Introduction to Stylometry with Python. So the reason this is a kind of classic example is that, of course, the Federalist Papers written between October 1787 and May 1788 were written by 3 different people using one pen name, one pseudonym, Publius. So it's complicated to kind of ascertain who wrote which papers. So Hamilton and Madison, so Alexander Hamilton, James Madison, and John Jay were the 3 men who wrote these papers. But Hamilton and Madison disputed some of them. Hamilton, I think 2 days before he fought in the duel where he was killed, wrote a note that claimed he wrote 63 of the 85 Federalist Papers on his own. But of course, Madison refuted some of that, said that he wrote, 12 of those that Hamilton claimed, and also he did most of the work on 3 more, that sort of thing. So, of course, these authors were writing about really closely related topics at the same time, a very condensed time frame. They're using the same kind of cultural and political references, really similar vocabulary. So it's hard to parse out and really track down, who could have written these based on their personal authorial styles. So it's been a dispute over a very long time, and it wasn't really until 1964 that two researchers, Frederick Mosteller and David Lee Wallace, using primarily word usage statistics, came up with a way to, try and parse this out. So what they ended up coming up with, because Madison and Hamilton had bizarrely similar styles, and something, I think their average, their vocabulary density was very, very similar, quantitatively, it was almost impossible to tell them apart. So the way that they did it was actually using those stop words. They were using really common words like may, also, and, his, and they used those in actually quite different quantities. So that's what they used to conclude that all 12 of the disputed papers were written by Madison. Of course, since then, other researchers have come through and said, you know, maybe Hamilton and Madison might have co-written more than were previously suspected. But anyways, this is really commonly used. You know, it's even a technique that's applied to things like music and art. So we kind of extrapolate and find ways of quantitatively summarizing or describing, you know, different musical chords. So another famous example of this was a paper where I think there was a particular Beatles song that both John Lennon and Paul McCartney claimed to have written. And authors were able to kind of quantitatively summarize the musical style of a song and compare that to a bunch of other Beatles songs with known authorship. And they concluded that Paul probably wrote the bridge because that was most Paul, but the rest of the song was definitely written by John. So anyways, really interesting sorts of projects and applications. So now take a quick break. If folks have questions before we dive into a particular tool that you can use to start to do some of this, a lot of the text mining and analysis approaches are really kind of require programmatic approaches. So there's a bunch of different command line, you know, Java programs and Python packages and R packages for doing this kind of work. But Voyant is a really great way of just kind of getting your feet wet. And you can actually do a lot with Voyant. So we'll look at that, but let's take a few minutes break and come back together at, let's say, 10:55. Does that work for folks? So I know this is a bit longer of a workshop, so feel free to, you know, walk away from your screen, go get a glass of water, take a few minutes to type questions in the chat while I get things set up for our Voyant demo. Awesome. All right, so let's come back together and look at Voyant. So Voyant is an open source tool. So that's kind of the first answer to the question that was asked about why I'm looking at this tool in particular. I think it's a great tool for folks who, you know, maybe you don't have a particular programming language that you already use, and you don't have, you know, maybe access to particular really expensive proprietary software. There's lots of software out there that costs a lot of money and will do a lot of these things, and it will have a fancy interface. I generally don't teach with those, and I don't use them personally. Because I'm not in industry doing this, you know, as like my day job kind of thing, but also because I think there are really fantastic open source options that are out there that are available for everyone to use for free and to, you know, add to and build on kind of as a community. So Voyant is an open source web-based tool created by Stephen Sinclair and Jeffrey Rockwell, who are researchers at McGill and the University of Alberta in Canada. And it is very consistently updated and supported. It has a robust user community. It's really commonly used by folks in the kind of digital humanities and digital pedagogy to start to teach some of these concepts of, you know, distant and close reading together. And it's fairly easy to use. So it's really the only robust kind of web-based version or, you know, application that does any of these kinds of processes. But of course, there's always a trade-off between kind of ease of use and power, or, you know, functionality and flexibility and customization. So Voyant is quite easy to use, but you don't have as much control over how the text gets pulled in and processed, right? That a lot of things happen in the back end. They're very transparent about what they're doing to create the things that you see. And in fact, let's just go ahead and hop into Voyant. So I'm going to just open up one of they have a couple of sample corpora. So I'm just going to open up their Shakespeare's Plays corpus, but you can bring in, and I'll show you later, you can bring in a body of text from a variety of different sources. You can upload, you know, a batch of different text files. You can pull things in from a website. There's a variety of ways to get stuff into Voyant. So this is what Voyant looks like. It is an interface with over 20 different tools, so that's why it's called Voyant Tools. And this is the default. They pull in basically 5 different little panes with a bunch of different tools that you can kind of swap in back and forth between, and they kind of center at first the reader. So really what you're doing here is getting a more kind of interactive version of the text itself, your documents themselves, and then you can kind of bounce back and forth between all these different tools that let you investigate your documents and the terms and phrases and all those things that are being kind of counted out. So the first thing I'll call attention to, let's actually talk about kind of the abstract, how you use this thing. So there is a language interface option. It's auto-detected by the text that you pull in. So if you pull in a bunch of Spanish text, it's going to assume that you want this interface to be in Spanish. But there's a bunch of different options for you to actually have this interface in a different language if you prefer that. And you can, what's really, really useful about this, if you do bring in your own corpus. So one thing to note, this is in my browser. If I click away, if I close out of this, if I, sometimes even just when I'm making changes to different things in here, it's a very ephemeral sort of interface. So if you want to ever save anything that you've created in here, you'll want to very purposefully do that, particularly if you like customize, and all of these are kind of customizable, they're interactive, right? So this is just a word cloud of the most commonly used terms in Shakespeare's plays. The corpus brought in. So we have the summary pane down here that tells us, we've got 37 documents. Here's the total number of words. There's all these different tooltips that help you out as we're looking at this interface. If you hover over things, there's these question marks everywhere that kind of tell you about each tool. Again, all trying to kind of help the ease of use for this, although I know it can look really confusing at first. So if you ever wanted to like save out anything from any of these, such as this word cloud, you can either, there's a little like export button. I think that's like the link, external link icon, but this will let you export, visualizations. You can export the charts that you create, visualizations in a bunch of different formats. And one of the most unique affordances of this tool is, say you do bring in your own documents, they will get stored on a server in Canada. So that's one thing to note. If you look at the privacy statement down here, they're really clear about what data they collect from you. They do use IP addresses. Just, if you do click away shortly, they'll save, your session, or if there's multiple requests in the same session. And they also use Google Analytics to kind of help them better, be informed as they update and improve the tool and understand how people are using the tools. They say, of course, that data is just used for research purposes and anonymous and aggregate forms. But here's something I want to call attention to. And I apologize if this text is really small on the screen. They say, please note that text submitted to Voyant Tools, and this is covered up by my Zoom stuff, are, gosh, I can't actually see it. I want to say it, let me see if I can. Okay, they are stored in order to allow persistent access during a work session and between work sessions. So when you bring texts in here, they are stored on a server in Canada, and you probably don't want to be bringing in anything that you don't have permission to, have leave your computer, things that are protected, sensitive data, information like that. But in general, things that you do upload are private just to you. They're not accessed by the creators of this tool. So just something to be aware of. You don't want to upload sensitive data, of course. But what this does allow you to do, because it's on their server and somewhere in Canada, you can export a URL to your particular corpus and to the actual view that you have created. So you can swap in and out tools. Right now we're looking at like 2 or 3 tools in each of these different boxes. But so here, because Shakespeare is one of their default corpuses, it says Shakespeare. But if I upload my own texts, this will be a string of numbers. That is the unique ID for my corpus, which we'll see in a bit. So this is really useful. You can bookmark this in your browser, you can save this and come back to it. So you don't have to kind of upload your text every single time you want to just play around with them. You can save this, you can share it with other people. So that's a super useful feature of this particular tool. You can also swap different tools in and out. And in fact, if you just click on this little Voyant Tools tiny text at the bottom of the screen, it will bring you to their help pages, which are really fantastic. So this is the documentation website. So they've got a lot more tools than what are immediately being shown here, and which we'll look at. This is just to say there's a lot of resources for diving deeper, because I'm not going to like go through how each of these individual tools works. It's also really interesting, or really important when you're looking at like some of the quantitative analyses in here. If they're applying an algorithm, you know, or like how are they, what calculation are they actually performing to get that, you know, if we go down here to correlations. So this is, it doesn't display tremendously well on my small screen, but I hope this is visible enough to folks. But we're seeing down here is the correlations between two different terms. And it tells you, it gives us information here as we hover over. This is a measure of how closely these term frequencies correlate. Of course, term frequency being, how many times the word occurs in the document versus the corpus, things like that. But if you're curious, like, well, how do they get these calculations? Then I recommend going into the help and then going down to the help page for that tool, and they will talk about, okay, well, we use this correlation as calculated by, Apache Math Commons library. So they kind of go into the calculations, so you can actually get that. That makes this a little bit more of a robust kind of research tool. So you can actually see what's happening in the back end. Although for kind of reproducibility purposes, programming environments, things like Python are they're going to be a little bit kind of more robust, obviously. But this is a good starting point. So what can we learn about Shakespeare from these? I'm going to answer that question, Cheryl, in just a second, about how would you do analysis of a website, just to kind of first show how we do an analysis of maybe something a little simpler, a series of plays, right? The series is just a word cloud of the most commonly used terms. So we're seeing here the total count, the raw frequency of the most commonly used words. So it's, a lot of these, Lord, King, Sir, Good, a lot of these are kind of salutations. So a lot of this is going to be really specific to this corpus and like the format of these texts where people's names are, and people are speaking directly to each other. People's names are listed. There's stage directions, things like that. But we could, for example, investigate love as a term that is used frequently in Shakespeare. And you'll notice as I clicked on love, there were some changes in some other. If the word love, which it does over here, in fact, well, it's not recognizing this word loves as that word love. So clearly the stemming did not happen. If this word love appears in here, it will be highlighted in yellow. There it is, to love. So we can see the document frequency just for Love's Labor's Lost is 103. So the word love occurs 103 times in this document. And in fact, we can kind of go through and over here in the trends, this is showing us how common is, how frequently are these particular words being used across the whole corpus. So, okay, Two Gentlemen of Verona, the word love, has the highest relative frequency within that document. This is kind of why it's important to move back and forth. Then I would ask, well, why? Why is love the most commonly, why is it most common in that particular document? Was that a particularly short document? How many total words were in there? What might be bumping up? If it's not something I expect, in the hypothesis that I have, or, if you're really familiar with your corpus or curious, like, why would that be, why is this? You can kind of move back and forth. So down in the summaries, this tells us all kind of quantitative information. So document length, we have this itty bitty little graph of the total number of, words in each of these 37 documents. It tells us the longest is Hamlet. The shortest is Comedy of Errors. So they range between 16,000 and 32,000 total words. Vocabulary density is the number of unique words divided by the total number of words. So of course, if we actually Click over to documents. This gives us a kind of summary view. So words here is just the raw count of words. We could sort this descending. So the document that is the longest is Hamlet. Types is unique word forms. So, you know, the word son, S-O-N, is a different word form than sons, than son apostrophe S, right? So this is unique word forms divided by total number of words. That gives us ratio, which is like a rough measure for, you know, vocabulary density. But of course, for very short, if we actually reverse this, for very short texts, you know, this doesn't have the straight up, you know, highest number of unique word forms. This might not even, anyways, this might not be the most, you know, linguistically rich play in a different sense. But it's useful to kind of have these numbers here and kind of compare, look back and forth. So that's that. So the question about websites. Yes, yeah, Kurt's question, does relative frequency take into account the length of the corpus? Wait. In certain tools, it does, and in certain tools, it's document length. So relative frequency here is, yeah, so that's, great question. So if you have a question about a particular tool, you can click over here and it's gonna take you right to that. So I'm curious, okay, well for trends, is relative frequency corpus length or document length? It does tell us it's the relative frequency across the corpus. So it's how many times does love appear in this document, this play, relative to the entire corpus. But, you know, great question. As you're kind of looking and having those questions, you can use the help and you can go back and forth between this and the documentation pages. So doing an analysis of a website. So I'm actually going to go up here to this little home icon and start over from, since I didn't really make any changes, I'm going to just go ahead and start over. So if you want to do an analysis of a website, you have a couple of options. You could straight up grab the URL for the website and put it in here and click reveal. And it will do something. What it's going to do, though, is pull in all of the, this is actually probably a really great example because it's mostly plain text, but, you know, sometimes you'll get all of these kind of like junk in raw HTML. So the way that Voyant's processing HTML, you know, you're probably going to get, you know, a mix of different like, you know, headers, and sometimes you'll get CSS tags and like other kind of junk things, you know, especially if you're pulling in from like a page that has advertisements or really complex, you know, ways that the web page is being dynamically generated or laid out. Because a lot of times this might be a static web page, but most pages online are not static. They're like dynamically generated when you look at them. That's when they're created. So in that sense, they're not just like a document. They're more complex. So a good intermediary step, if you do want to use this kind of thing to analyze a website or different web pages, is to do something like if your browser has, you know, reader view, I know like Firefox and Chrome both have options to kind of strip out all that extra junk. If you just want, it depends on what you want to analyze, right? If you just want to analyze the text of a website, then it might be best to grab that text in some process and then save that as a text document or whatever, and then bring it into Voyant, if that makes sense. Because I think if your purpose is like investigating the junk, right? Maybe you are interested in finding particular, you know, like how much space is given to ads or, you know, things like that on different web pages. It's just a little more complex than just text documents, is my point. Great question though. So let me show you all what it looks like to upload my own documents. So I believe I have. Oh yeah, I have on I have a folder of inaugural speeches. These are just text documents with all of the inaugural speeches of, I'm missing George Washington. I don't know what happened. I definitely had those at some point, but for some reason they're not in here. These are otherwise all of the text documents or just text from different sources, mostly Wikipedia, of the inaugural speeches, presidential speeches. So I'm going to select all of them using a keyboard shortcut. It'll be different on different operating systems, and pull them all in at once. So now you'll notice up here, before it said corpus equals Shakespeare, now it says corpus equals this long string of letters and numbers. This is my unique ID. And this corpus is now of these, 48 documents, it should be 50, is stored on a server in Canada with this unique ID. So I can now, if I don't want to have to bother uploading that, I could even change out some of these. So if I don't want Cirrus to appear here, or maybe I don't want correlations, I can swap these out. So you use the little window icon. Not sure why, but that's the icon that lets you swap out different tools. So if I want to, grab bubble lines, is another kind of interesting way to visualize different words and where they occur across different speeches, right? So these are the most commonly used words in this corpus: government, people, states, great country. Makes sense. But if we wanted to, investigate particular things, we can investigate them. The word citizens is used most by Bush 2001. Interesting. So yeah, if we wanted to export your particular corpus and particular view of your corpus, you've maybe swapped in and out different tools, you can now go up to this little export icon up here and export the entire, this entire app. You could also export it as an HTML snippet. That's going to be like an iframe that you can embed in other websites. Either of those are good options. This is the one where it's going to, recreate this if you leave and then come back a different day. And they say, as long as they don't kind of promise how long your stuff's going to be available, but they do say it should be available. Generally speaking, it will remain accessible indefinitely as long as you go in and access it once a month. They probably do a refresh, and clean out their server every now and then. So you can refresh it by accessing it once a month. But yeah, I just created, so this is the page I was originally on, and then I created that. This is now the full URL to this particular view that I created. And I can come back and access this later if I bookmark it. So that's really, really useful to know. You can also export, as I was saying, I think I started to say, and then didn't kind of follow through on, you can export individual views. So I can export just this little Cirrus word cloud. Again, I can export a URL for this view. That's going to just be a view of just this one little tool. So this can be a useful way of sharing with other people. Again, it's to my unique corpus. I can also export the view as an HTML snippet. So if I do this, it's going to give me the iframe code, and they have little embedded instructions in here, like you can change the width if you want, to have a wider or smaller iframe. So you copy and paste that into your other website, and you can export it as a static or so different tools have different export options. But you can export this as a static image. So it'll generate an image of this, so I can just view it in theory. Well, you can, something's happening with my Firefox, but you can view this image and then save it as an image. I think my Firefox is frozen. I have too many Voyant windows open. That can happen too. It can kind of bog down your browser. It could also be because I have Zoom open. There's a lot going on. So it seems like that has frozen, unfortunately. You can also export as an SVG file, which is, okay, things are happening. There we go. Okay, so this is the static image. So I would go in here and save this image, right? Oops. And you can export as a scalable vector graphic, an SVG. So that's a little better if you want to take your chart, and tweak the colors or things, tweak the elements in like something like Adobe Illustrator or another, vector graphics processing software. So you can export that SVG. Again, same deal. So different options for, exploring this and getting things out. Okay. Other questions about Voyant in particular, or thoughts on how you might use this particular tool? It's a great tool for kind of just diving in and exploring a corpus, exploring documents, doing some of these really simple kind of counting statistics. It's a great tool. You don't have to download and install anything. You don't have to know how to program in Python. But again, it doesn't have as much functionality. It's not as flexible as some other things. Let me pop back over here to my slides. So I actually do have a couple of other tools just to showcase. Oh, you know what? I believe I still have this open in another window. Do I? No, apparently not. Okay. Okay, so as I was saying, Voyant is the only tool that I really know of that is of its kind in terms of being super easy to use and browser-based. There are other, of course, kind of proprietary desktop software that do these things, but I wanted to call out a lot of some of the best open source options for if you want to kind of explore further on your own. And just be aware of what's out there and some of the pros and cons of kind of going down one of these different paths to do some text analysis. So there's command line, like Java-based programs you run at the command line. Some of them do have interfaces. Stanford Core NLP is a really fantastic one. There's also something called Apache Open NLP. That's a little better if you want to do a lot of your own training and stuff. But Stanford Core NLP has a lot of out-of-the-box functionality. There are also some really fantastic Python toolkits and packages, and a couple of really great R packages. What I will say, I have done text analysis in R, and I generally would recommend Python. If you're sitting and debating, like, should I learn Python or R, and you primarily want to do text analysis, choose Python. Not only because it has some really great resources, but it really is intended to work with text in a different way than R. In terms of like R's data structures, there's ways you can work with text in R, but it's not really intended for that. So yeah, this is just a summary of some of these tools. I'll probably just kind of breeze through this since we're running a little low on time, but if folks have questions about any of these in particular or are curious, yeah, again, link to the slides. I'll share it again at the end. So you can always go back and check these out. And I've included a suggested learning resource. I have not used Deduce. I know, let's see, Kurt, I think there's some other folks in the meeting today who do use Deduce. If you have thoughts on that, please share. But something that I'm interested in doing moving forward is to put together some of these kind of pros and cons across different tools into a kind of tool matrix or, a module. So hopefully we'll be able to make some of those in the coming year and share those on the library website or something similar. So stay tuned for those. Oh, Kurt hasn't used Deduce. I apologize. I thought you had. So I'm sorry, Cheryl, I don't have thoughts on Deduce, but that's something I can look into and we can kind of have a conversation later if you're interested. So Voyant Tools is the only one of its kind. Stanford Core NLP is a Java package run at the command line. It is a really robust kind of text analysis package, and it is fantastic for working with multiple languages. So some of these NLP and text analysis approaches will claim to be language agnostic, which is problematic because training corpora and all of that really matters in terms of how the algorithms run. And some of them are better at dealing with some languages, or maybe they were designed by folks who are English speakers with English speaking, English language in mind. So they're not as good at other, processing other languages. So it is good to look and see how these different programs handle text from other languages. Made by folks at the Stanford NLP group. And there is a tutorial linked here. Mallet, oh, I forgot to link Mallet. on my original slide. So Mallets is another Java-based package for NLP, primarily used for topic modeling. It also has some other advanced text analysis methods built in. And it was built by folks at UMass Amherst and the University of Pennsylvania. So into Python packages, the natural language toolkit is by far my most highly recommended. Great question in chat. Do we need permission from the website owner to do data mining? So I think it depends on how much information you're scraping. But in general, if a website is public, you can access that text. Again, it depends on what you do with it, because just because something's online doesn't mean it's free to use, right? There's plenty of copyrighted materials, copyrighted website, copyrighted articles on text, right? Or articles online. So it depends on what the website content is. If it's a public website that is not copyrighted, or if it has an open license on it, then you're able to you don't have to get permission from the website owner to do that. So that really depends. Good question though. So the natural language toolkit, very briefly, is fantastic if you're using Python. It comes with a bunch of different corpora in different languages, as well as pre-trained models, also created by folks at the University of Pennsylvania. So this is a really fantastic option if you do want to use Python. There's a great a book here about the natural language toolkit. SpaCy is another option in Python. It actually uses Python and Cython, which is like Python and C combined. But it's also, it has a bunch of advanced machine learning methods, works on multiple languages. It's a little more robust, or industrial strength is the phrase that that they use to describe themselves. And then there's a couple of R packages you might investigate. If you do use R, you don't want to use something else, you can kind of do some text mining in R. In fact, the text mining and processing is what R excels at. It's less great at implementing a lot of the kind of more robust machine learning algorithms. So tidytext uses the kind of tidyverse, tidydata format for storing this text. And then Quantata is another great option created by someone from Australia, a little more advanced. Okay. Yeah, great question, a great conversation in chat about deduce and qualitative analysis versus text analysis. Yeah, and there's so much work. This is a huge kind of area. We just scratched the surface today. Again, I encourage you to, submit questions, email me directly. I'll share my email again in chat. But also feel free to go to the library website, to our Ask a Librarian, and submit questions through there. And if they're about, text, we have a data librarian who actually offers hockey hours and other programs to support, if you have questions about using R or Python, things like that, or other questions about text analysis will get routed to me. Yeah, you know what, let's, and if folks have specific questions, do definitely follow up with me. I'm seeing some specific questions in the chat. So I'm going to stop the recording now, but I'll stick around for a few minutes. Thank you all so much for participating. I hope that this was useful, and we will make this recording available.